So look at this iron. When it loses two electrons, the 4s2 electrons are lost and becomes 3s, 3s2, 3p6, and 3d6. So totally 14 electrons in the outermost orbit. So when one more electron from the d orbital is lost, totally 13 electrons in the outermost orbit. Now it becomes a stable configuration after losing the one electron from the d orbital. It becomes a stable. Similarly, cobalt 2 plus 15 electrons in the outermost shell, and cobalt 3 plus 14 electron. Similarly, nickel 2 plus 16 electrons, nickel 3 plus 15 electron. So in general, I can write S2 P6 d power x means that is x electrons can be accommodated. The x can be 6, 7, 8. So Fe3 plus, cobalt 3 plus, and nickel 3 plus, they are all stable due to effective nuclear charge. This is the entire picture of the effective nuclear charge. So you can see how the iron 2 plus is formed, how the iron 3 plus is formed. You write the electronic configuration of a cobalt with its electronic configurations, and nickel with electronic configurations, and see what happens when 2 electrons are removed and 3 electrons are removed. So these configurations you have to write by yourself and see how it is attaining stability after the loss of 2 and 3 electrons. So the outermost orbit is containing the d orbital, which is almost diffused. See why the name d has come. S for simple, P for primitive, and D for diffused, and F for fundamental. That is how the orbital names have come. D orbital is a diffused orbital, and also it doesn't show degeneracy. See, when it is present in the crystal field, it is getting split up. So it can lose one electron after the other, whereas P orbitals are degenerate. If you supply energy to remove the electrons, all the 6 electrons will leave the place simultaneously, but it is not so in the case of d orbital. Electrons will leave one after the other. So you can remove one electron from the d orbital, whereas these 4s orbitals are separate. Its energy is separate. So these 2 electrons will leave to form Fe2 plus. In addition to that, if one electron from the d orbital goes, it forms d5 electronic configuration. So then the ion becomes iron 3 plus. So this is how the variable valency cations are formed. And because of this variable valency, d orbital metals are having very peculiar behaviors like variable valencies, and they show catalytic activity, and also they form colored complexes where salts are colored, and they show catalytic activity, and they also form compounds of variable valency. And these are all the important things you have to learn about the transition metals. So the next one, it is also very important how copper plus and the copper 2 plus ions are formed. Look here. Actually, the copper electronic configuration is a 3d10 4s1. 3d10 4s1. Actually, it is supposed to be 3d9 4s2. But when this one electron is shifted to D, D becomes completely filled and S becomes half filled, both attain stability. So it is 3d10 4s1. So when this one electron is removed, it is 3d10 with the 18 electrons in the outermost shell. When one more electron from the 3d is removed, it becomes a 3d9. As the d orbital is diffused, 3d9 is equally stable. So now it gets 17 electrons. Actually, the copper 2 plus, the stability, the energy that is needed to remove the further electron is compensated by the lattice energy of the salt for copper 2 plus and gold 3 plus. What is lattice energy? I have already told you. Lattice energy is the energy released when ions are brought from infinite distance to the exact position of the lattice point in a solid crystal. Similarly, take zinc. Zinc 2 plus is stable because of 18 electrons in the outermost shell. Similarly, mercury 2 plus is also stable because of 18 electrons in the outermost shell. So the magic number 2, 8, 8, 18, 32. If 18 electrons are present in the outermost shell, it is stable. And also it is stable due to high nuclear charge. So as they get 18 electrons in the outermost shell, they will never go beyond the +2 oxidation state. Similarly, cadmium 2 plus. Cadmium 2 plus is also 18 electron. It gets 18 electron in the outermost shell. It is also stable. Now, the properties of ionic compounds. What are the properties of ionic compounds? First property, the ionic compounds conduct electricity. In solid state, they do not show any conductance because the ions are very rigid and they are got held up in their positions. So they are not able to move here and there to conduct the electricity. But when you rise the temperature, their bonds will break and they are free to move. So ionic compounds conduct electricity either in the molten state or in the solution state, but not in the solid state. And secondly, because of the high crystal lattice energy and also due to the strong electrostatic attraction between the ions, ionic crystals show very high melting points because the force of attraction between oppositely charged ions is very high. So more amount of energy has to be spent to break the attraction. So ionic solids are high melting.